for various levels of income, that is the budget line, we can derive the various equilibria, and by joining them we get the income consumption curve or income offer curve. Here we are going to derive it mathematically so that we get some concrete answer, because a diagram can be helpful, but the equation in mathematics can give us the opportunity to put the empirical data in it and then to come up with some answers that can guide our policymakers. So here we have a situation where we have a utility function of a household and they are consuming two goods, that is x1 and x2. And we have the utility function here in this form, which is a logarithmic utility function in which both of the variables, that is x and y, they appear in their natural logarithmic form. And it is constrained by a certain constraint, which is a very famous constraint. Budget line is there. We know about this already. To do the constraint optimization, we make the Lagrange function from it, and the Lagrangian function is written in this way, that the objective function, that is the utility function, it comes in the beginning and then we add this term in it, and that term is basically the product of the lambda, that is the Lagrangian multiplier, and an inverted form of the constraint where we have kept the value of the constraint, that is budget, on the same side, that is the side where its sign is not changing, whereas we have shifted the other two terms to this side. So this is the decorum of making the Lagrangian function that we have done here. The next step after this is definitely to develop the first order conditions, and for that what we have done is we have developed these three first order conditions, and these are basically the derivatives in the partial sense with respect to the three variables or parameters involved, that is x and y and lambda. So these are the partial derivatives that we have calculated. They are put equal to 0 because this is the requirement of the first order condition, that we keep it equal to 0 as it is a stationary point and the slope with respect to all of the variables should be 0. So now we have the solution, the first order condition here, the first one is here, and this is the second one, the second first order condition, and this is the third first order condition, and we have saved them as equation 1, 2 and equation 3. Now we have to solve them simultaneously because there are three unknowns in it. One is the value of x, other is the value of y, and the third one is the value of lambda, the values that we want to know. And there are three equations, so it becomes a system of simultaneous equations that can be solved in a certain way. Primarily we take the first of the two first two of the three first order conditions, that is this one and that one. From these two I can extract the value of lambda and I can equate these two values of lambda. Here the extracted value of lambda from the first equation is this, and this is the value of lambda from the second first order condition that we have developed in the last step. So these two can be equated, so this is why I am equating this value to that value, because both of them are equal to lambda. Now I can rewrite it in some meaningful way. This is the way in which I can write, for example, the dependent variable as a function. This is the dependent variable as a function of the independent variable. Other of the values, that is py, px, they have been shifted in such a way that the dependent variable remains the only term on the left hand side. Now I can write it in this more readable way, and this is actually the income consumption curve or the income offer curve, and you can see that how easily we have developed this curve. This is what it is. And if I look at the variables involved in it or parameters, I can see that there is px, there is py, and there is x. As you can see, px, py and x. These are the three variables or parameters involved in this. This is how it looks like, the indifference curves between x and y and the equilibria, and then we join these and we get the income of a curve. Now we can also do a little bit of further useful calculations, then that is to find out the demand function for good x and for good y as well. So let's start with good x. In this process we will use the income consumption curve that we have developed, and we will use it with the third of the first order condition. This is the third of the first order condition. Let's go back and just verify. As you can see, this is the third of the first order condition, and in this condition that I have rewritten here, I'm going to put the value of y that I have found in the income consumption curve. This is the value, and in the next step you can see I have substituted this value as it should be, and straight away I am able to cancel out the value of py here. Its symbol is now gone, and now I am left with this term, and in this certain situation px is common, it is extracted, and now I can extract the value of x, which I am in search of, by shifting all these terms to the right hand side. And when I shift it, there's a little bit of reciprocalization, that's why it becomes 9/16, and px appears in the denominator instead of the numerator. So this is the critical value of x graphically or mathematically speaking, because these are the values that lead to the maximized value of the dependent variable, that is utility or the objective function. In other words, in economic sense, this is actually the demand function for good x. It is because it is the dependence of good x, its quantity, on the price of good x. So it means that it is the demand function, and it should also satisfy the inverse relationship between the two variables, which is the standard of the law of demand. And here we can see that it is happening because px is in the denominator, so there is an inverse relationship here. As we can see, it is quite clear. We can also do this verification by using the derivatives. As you can see, I have borrowed this demand function that I just devised, and I took its first derivative. When I took the first derivative by solving these two steps, I will get to this value. You can do these two steps very easily because it is simple differentiation. When I did this, I got this answer. This basically shows that the answer is negative because 9 and 16 both are some positive values. Income or budget is usually positive and it cannot be negative. So this is why I have written it here. And the price of x is definitely a non-negative value, it cannot be negative. So both of these variables or parameters are non-negative, due to which this expression will be non-negative, and this is also already a positive value. So when we solve these two expressions, we get a positive answer, and this negative sign actually reduces that positive answer into a negative answer. That is why we can say that the answer is negative. And the answer of the derivative of the demand function shows that there is a negative relationship between price and the quantity demanded of good x. The price of x and the quantity demanded of good x. So it follows the law of demand. So now we are sure that we have developed the demand function. Now we can also see the shape of the curve by using a simple further derivative. We have already calculated the first order derivative. I can calculate yet another derivative, and this is how I can do this. The derivative of the already calculated first order derivative that we did here in our last step. So it will make it the second order derivative. Now this is a set of steps that you can do easily, because this is simple differentiation. Simplification should lead you to this answer, which is 9/8 into I over px cube. These values have already been proved to be non-negative. This is also a couple of values that are positive, so the answer will be positive. When the answer of the second order derivative of the demand function is there as a positive value, it is a positive value, it means that we have a convex indifference curve. So this is that condition that we wanted to satisfy, and I and px are already verified to be non-negative. So we have done some analysis of the demand function of good x. Now we can devise the demand function for good y, and again I can use the same equations that I have been using before. The income consumption curve can help us in this regard. This is that income consumption curve. I have already found the value of x, that is the demand function, so I can put this value here, which is actually this value, and when I have substituted this value in the income consumption curve, there is a little bit of cancellation that can happen, that is px and px and 9 and 9. So these are some values that have been deleted because they are cancelled out in the next step. So this is the demand function for good y. It shows the critical value of y, because it is a stationary point, and it helps us to find out the maximum level of utility. From the economic point of view, it is the demand function for good y, and if there is a relationship of inverse nature, then it should look like this, that is the inverse proportionality should exist. And here we can see that it is evident because py is appearing in the denominator, that is the price of good y. So it is already visible, but we can also experiment with the first order derivative. We have done this. You can pause the video, go back to the first order derivative with respect to x, and see that how this was calculated. It is quite similar, and you will find that all these values are non-negative. So this negative sign will make this value a negative one, and these are various reasons for that. So the law of demand will hold in this case as well, where we are talking about good y. We can also judge the shape of the indifference curve simply by taking the second derivative of the marginal version of the demand function of y. So we have done that, and once we did this, we got this answer, which is actually a positive value, because all of these are at least non-negative. So the positive answer of the second order derivative of the demand function is actually showing that there is convexity in the indifference curve, which is the standard form that we usually observe in the indifference curve analysis. So here in this video we did a little bit of analysis of the demand functions, for their relationships, for their shape of the curves, and we developed them by using the income consumption curve that we developed by using the Lagrangian function method of constrained optimization. This is the diagram of it, this is the equation of it, and it was developed by simultaneously solving the first order conditions that we developed by using the Lagrangian function, and that was developed by resorting to the given information, that is the objective function and the constraint function. So this is how we can mathematically develop the income consumption curve. Thank you.